Everybody, today we're going to be looking at graphing sine and cosine, specifically the parent functions of both of those. So this is one of those lessons where I really want to take the time to build where stuff's coming from instead of just giving it to you. So we're going to be looking at both sine, cosine today. We're going to skip over tangent for right now. If we have time at the end of the year, we'll come back to tangent. So first off, start by making sure your calculator is set to degrees. We're going to start out in degrees today, and then we're going to transition over to radians. So again, make sure you're in degrees. So graphing, we typically use a table of values when we're creating graphs. So let's start out. We're going to start with 1 or 0, and let's go up to about 12. See what that does for us. 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And you could go up and fill out this whole thing. It's not gonna make a huge difference for what we're doing today. Okay, so looking at that, we want to graph sine first. So let's do sine of x. Okay, and then we're looking at the table. So we're gonna hit second table. Okay, and then here's my values. We're going to shift this over just a little bit. Where'd my calculator go? There we go. Perfect. And then we're going to put these in. So we've got 0, 0.02, 0.03, 0.05, not going up by a whole lot, 0.07, 0.09, 0.10. Scroll down, get the other ones we need. 0.12, 0.14, 0.16, 0.17, 0.19, and 0.21. Okay, so it looks like most of these are going up by about 0.1 or 0.2 each time. Or sorry, 0.01 or 0.02 each time. So if I take this and put it in a graph, we're starting at 0, so we don't need to necessarily graph like we would normally do, where we have the graph or the y-axis in the middle. So we're going up to 12. So let's just count by 2. So 2, 4, 6, 8, 10, 12. And then the biggest number we get to is 0.21. So let's just say 0.25 even. So we can count by 0.05, 0.1, 0.15, 0.2. Okay, so at 0, we're at 0. At 1, we're at 0.02, so up just a little bit, 0.03. And we can skip over some of these. We don't necessarily graph them all. Let's do it just by 2. So 0.4 would be 0.7, so about right there. 6 is 0.1, so right about there. So 0.14, right about there. Maybe even a little bit high. 10's 0.17, so right about there. And 12 is 0.21, so right about there. And there's my graph so far. Okay, and it kind of looks like this is a very linear graph. And if I head over to my calculator again, that's what I'm going to see as I'm graphing. And even it kind of looks kind of hard to see. So let's adjust the window there. Because the highest we went from 0 to 12, and let's make it a -1 just so we can see that left side just a little bit. And then we went up to 0.25, so let's go -0.25 to 0.25. Oops, 5. Oops, I had something wrong there. So, window. Oh, I see what I did. So we want to do, sorry, 0.25, -0.25 to +0.25. There we go. And then let's just set this to 0.05 because that's what we counted by. And we could even go here and say 2 because that's what we counted by there. Okay, and there's my graph. And again, it looks fairly linear as to what's going on here. But if I take a second and I zoom out, This may or may not work nicely for me. Let's see how it works. Okay, still looks pretty linear. Let's do it one more time, see what happens. Okay, and hold up, starting to look like it has a curve. And wait a second, it kind of looks like it came down on this side. Let's do it one more time, see what happens. Okay, now it's too hard to see, but it looks like it's staying pretty close and it's going up and down. Let's do this. Let's set our y to, let's say, -1 and +1. I'm picking those numbers on purpose. You'll see why in a second. Okay, and that's not what my graph looked like at all. The reason that this happens, the reason that my graph is kind of freaking out here, whereas on my original it kind of looked like a linear line, is because of the scale. So remember, when we talk about a circle, right, and things repeating on a circle, we're talking about 360 degrees. And for me to really see that, and if I look at my window here, it's going up to 360 degrees in both directions. Let's change this just a little bit. Let's go to 1,000. Excuse me. So at 1,000, I can see that it starts repeating really nicely. Okay, but it takes me to go to 1,000 to really start seeing that pattern. Even arguably at about 720 is when you would really start seeing that pattern. So this isn't super conducive. So let's try one more thing. Let's do the same idea, but instead of going by ones, let's go by tens. So 10, 20, 30. Actually, let's go by 20s. It's going to be even better for us since we're not doing quite as many. 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, and 240. Okay. Now, a couple calculator pre-ACT tricks for you, ACT tricks for you. So I can hit second table set, and I can tell it where to start and what to count by. Okay, in this case, I wanted to count by 20s. Oops, not graphing, we're using the table. There we go. Okay, so there's my numbers. Let me shoot this down again. Okay, so I've got 0.34, 0.64, 0.86, 0.98, 0.98, 0.86. Scroll down, or 0.87, I guess technically. Sorry, round correctly there. And then 0.64, 0.34, 0, negative 0.34, negative 0.64, and negative 0.87. And that should also probably be a 7 there, actually. Okay, so taking this, graphing this one out, now I can see my graph goes from negative 1-ish to positive 1-ish. We can chop that up a little bit. 0.5, 0.5. Okay, I'm going all the way up to 40. Let's count by 20. So 20, 40, 60, 80, 100, 120. 160, 200, close enough. Okay, so start at 0. 20 is going to be at 0.34, so right about here, and then here, and then here-ish. 80 is at 0.9. Starts dropping down again. 140 is at 0.64. 160 is at 0.3, 0, and then it seems to go in the same numbers, but negative. So right about there. Okay. And now we can see that curve a little better. Okay. So the problem here is that we, again, kind of what we saw earlier, we really have to go from negative, or we have to go from 0 to like 1,000 before we really start seeing that pattern repeating. So degrees really aren't really very nice for us here, which is why, again, we have radians. Radians work a lot nicer. Remember what we talked about before, when we looked at radians, a circle was 2 pi. radians. Now, 2 pi is about 6.28. It's a much smaller number to deal with. And if I'm doing 2 complete cycles, that's about 12-ish, a little bit more, 12 and a half. So when I think about those numbers are much smaller. And I'm not having to go out to 1,000 to really see those cycles happening. I'm only having to go out to about 12.5. So radians are much nicer when it comes to dealing with that. So go ahead and swap your calculators to radians. Remember to do that. You just go to mode and you click on radians. And we're going to stay in radians for this pretty much this whole unit. Okay, so last unit we wanted to stay in degrees. Now we're wanting to stay in radians. So now that we're in radians, let's do the same idea. Okay, but I want to be careful about the numbers I choose here. We said 2 pi is about as big as we want to go to see one cycle because we think that's about as big as a circle. So we want to go to 2 pi. Let's do it by pi over 6. So I'm going to go 1 pi over 6, 2 pi over 6, so on, 3 pi over 6, 4 pi over 6. And these, of course, some of these would simplify down, but I'm just making it easy here. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. And again, some would simplify down, but don't worry about that for right now. 11 pi over 6 and 12 pi over 6. Okay. So going in, doing the same kind of thing. Now my calculator's in radians. Now, again, an ECT trick here I can do. I can start at 0. And I can actually even count by pi over 6. I just have to go pi divided by 6, hit enter. Okay, and that's about pi over 6. Okay, so table. And then we're going to throw this over here. So we're at 0, 0.5, 0.87, 1, 0.87, 0.5, 0, negative 0.5, negative 0.87, negative 0.5, 0, 0.5. I skipped some. Hold up. Sorry. Yep, I did. Apologize. Let me go back. Okay, so negative 0.5, negative 0.87, negative 1. There we go. Negative 0.87, negative 0.5, and 0. And then if I kept going, I would see that this number pattern repeats, that 0.5, 0.87, 1, 0.87, 0.5, so on and so forth down the line. Okay, so graphing this one out, again, I'm only going up to 1 and negative 1. Let's put those middle lines in for those 0.5s, just so we have a point of reference. And then we're going to count by, let's do 2 pi over 6. 4 pi over 6. And really, these would be like by pi over thirds. 8 pi over 6. 10 pi over 6. And 12 pi over 6. Okay, so starting out, we're going to be at 0. Okay, 2 pi over 6 is at 0.86. Okay, I do want to go ahead and put this 3 pi over 6 at 1, just so we know the highest point here, 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 sorry, down here, here, and then here. Okay, so I get this nice curve. And there's sine. Okay, now remember, this does repeat forever in both directions. Okay, and if I graph this and I just go to the standard zoom, okay, it's much easier to see. Now, again, I probably would want to adjust the window to just go to like -1 to 1 or -2 to 2. Oops, sorry, that was the wrong ones. Go back, go back, go back, go back. Let's try that one more time. Window, we want to adjust the Y's. Sorry about that. Okay, and I can see again that nice curve over a much smaller space. Okay, at 10, from -10 to 10, I get almost 2. So let's see, 1, 2 and a half-ish oscillations on that curve. almost actually 3 total oscillations on that curve, which is really nice for us because it lets us see that curve oscillating back and forth. So that's kind of the goal for this, is to get that. That's where this parent function is coming from. So the next thing I need